Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Now the topic for today's lecture is we are going to discuss three-phase power measurement. Okay, it means we are going to see how the power is measured in three-phase circuits. Fine. So basically we are going to talk about an instrument called wattmeter. Okay, wattmeter. So basically a wattmeter is an instrument which is used to measure the power. Okay. Now, why do we require a separate power meter or wattmeter here? Because when you talk about a DC circuit, the power in DC circuit is going to be VI, right? P is equal to VI. So it is simply the product of voltage and current. But as far as AC circuit is concerned, here you have, active power, you have reactive power, then you have the total power, correct? So what is active power here? Active power is the product of RMS voltage, RMS current and the power factor, right? So if you measure the voltage by using voltmeter, current by using the current meter, and if you simply, multiply it, you won't be getting the power of AC circuit because here you require the power factor also. Fine. So if you want to measure the power in AC circuit, you require a special instrument. Now, wattmeter does this job for us. Okay, it also measures the power factor. Fine. So let us see what exactly is meant by this. So basically, three-phase power measurement is done by using 1 wattmeter method and 2 wattmeter method. Now let me tell you that in our syllabus 1 wattmeter is not included. It is specified that we have to discuss or we have to cover 2 wattmeter method only. Now before talking about what is 1 wattmeter and what is 2 wattmeter, well, 1 and 2 indicates the number of wattmeters used. Fine. So essentially a 2 wattmeter is going to contain 2 wattmeters. So it measures two powers, W1 and W2. Fine. Let us not discuss first 2 wattmeter. Let us quickly see how a wattmeter looks like. Fine. A normal wattmeter, how does it look like? Fine. So basically here we are going to have an AC signal which is getting applied. Okay. And here I have a load. Fine. So this is my load. Now this is the current which is flowing through the circuit, and rather I should say, yes, okay, let it be. So now here I need to connect the wattmeter. So how does a wattmeter look like? Now here it has a small coil. Okay, it has a small coil. Now please remember that if I am taking a single turn, it means it has a meaning. Fine. It means it is a small coil. Okay, then it has another coil, but it has more resistance. The resistance of that coil is very large, and hence it is represented by a resistance. Fine. Please understand that it is also a coil and this is connected here. So this is the connection. Okay, together this assembly is called wattmeter. Now wattmeter has two coils. Okay, this coil is known as current coil, and as the name suggests, it obviously measures the current. Its job is to measure the current. Now this coil is called pressure coil or potential coil. Now what is potential coil? What is the job? The job of the potential coil is to measure the voltage. Fine. Now this current coil has two terminals. Okay, terminal 1 is called N, the second terminal is called L. Similarly, pressure coil also has two terminals, one is called C and another is called V. Now here M stands for mains, so this terminal is always connected to mains. Remember this, it is always connected to mains. And L stands for load, which is obviously connected to the load. We cannot interchange these points. Fine. Now, as far as the potential coil is concerned or the pressure coil is concerned, here C stands for, no, it doesn't stand for current, it stands for common. Fine. Okay, and here V stands for voltage rating. Okay, now see, the current coil basically, if you talk about the current coil, it actually behaves as an ammeter. What is the characteristics of ammeter? Ammeter has very small resistance. Now why does it have a very small resistance? So that maximum current can flow through it, because we want to measure the current. So the current should be as large as possible. So in order to satisfy that condition, the resistance of an ammeter is always kept very low. Now similarly, if we talk about potential coil, what is the job of potential coil? Potential coil is used to measure the voltage. So it behaves as a voltmeter actually. And it has a very high resistance so that it gets maximum voltage across it. Fine? Okay. Now, a very important point here is that this current coil is always connected in series with the load, and this pressure coil or voltage coil is potential coil, sorry, is always connected in parallel with the load. Okay, fine. And as I said, the resistance of current coil is small, but its cross-sectional area is large. Okay, and it has less number of turns. Fine. Now the wattmeter reading depends on its connection. Okay, and secondly, here a very important point is the wattmeter also senses the angle between what? The angle between the obviously voltage and the current. So it actually senses the current phasor of the current coil and the voltage phasor of the pressure coil. Fine. So let us see how this is represented. I just want some space, so I am erasing this. Yes. So the reading of the wattmeter is represented by W, and it actually gives me the voltage. What is the voltage? Voltage across the pressure coil multiplied by the current. Which current? The current which is flowing through the current coil, multiplied by the power factor as well. What is the power factor? It is cos phi. What is phi? The angle between the voltage and the current, and the unit is watts. This angle shows, this symbol shows angle. Okay, I hope you understood the job of how wattmeter looks like. Fine. Okay, now we will be talking about two-wattmeter method. So this is how two-wattmeter is connected. Fine. So obviously here you have two wattmeters, W1 and W2. This is a three-phase winding connected in star fashion. Okay, you have three-phase windings R, Y and B. Two wattmeters are connected. Now see, logically speaking, if you wish to measure the power between one phase, for one phase you require 1 wattmeter. But if it is a three-phase meter, logically speaking, we should require 3 wattmeters, isn't it? But actually 2 wattmeter serves the purpose. Now of course we are going to see how does it perform its job. Fine. Okay. Yes. So here what we are assuming is that the load is inductive, so that the current lags behind the voltage. Okay. So here this is the phase voltage. This is a phase voltage, this is the neutral point. Okay, so here you have R, Y and B. So what is going to be the voltage between these 2 points? It will be VRN, correct? Similarly, the voltage between these 2 points will be VYN, and here the voltage will be VBN, right? And this is the line voltage. Okay. Now, if you carefully see, this line voltage is between these 2 points. What is there between these 2 points? See, we are moving in this direction, correct? So what is there between these 2 points? It is VRN and VYN. So what will be this line voltage? The addition of these two. Fine. I'm just telling you how we can calculate different voltages. Fine. Okay. Yes. So now let us talk about, now secondly, yes, of course, we need to discuss something else as well. Now this is a three-phase voltage. Now the voltages, they lag, they have the phase difference of 120 degree with respect to each other. Yes. Secondly, since it is a balanced system, all the phase voltages are equal, correct? So this is the characteristics of balanced system. Secondly, since it is a star connection, here again the phase currents are same. So these three currents are same here. And anyways it is same because we are talking about the phase current, isn't it? So all phase currents are same for balanced system. Fine. So what is going to be the wattmeter 1 reading? It will be the current flowing through that is IR. And here it is connected between this, the voltage. I'm talking about the voltage coil, this and this. Okay. So it gives you the voltage multiplied by the voltage. What is that voltage? VRY multiplied by cos. Angle between VRY and IR. Okay. Now to understand all other things we need not bother. All other things, by that I mean these two. We need to bother about this. Now how to find out the angle between these. So for this we need to understand the phasor diagram. Now we will be talking about the phasor diagram. So how do we plot, how do we draw phasor diagram? For this what we do is we first take a reference. Okay. So suppose if I take reference as VRN, then I would be drawing three phase voltages VYN, which are 120 degrees out of phase with each other, correct? So this is VBN. Okay. Yes. Now since we assumed the current to be lagging because the load was inductive, here I would be drawing the corresponding currents. So it is IR. This one is IY. And this one is IB. And this phase shift is phi. All corresponding phase shifts are Y. Now in order to find the resultant voltage, I am going to extend this. Let me use some other color. Yes. So I am going to extend this here. So this becomes minus VYN, which is actually VNY, right? We know that if you reverse the term, the points, the voltage is also reversed. Similarly, I will extend this point here. So it becomes VNB. And here also. So this becomes VNR. Okay. So which color I should use? I will use black. Fine. So when I draw the parallel lines here, now this is the resultant voltage. Okay. Similarly here. So this is VRY. Okay. Similarly, this is VBY. Okay. Now in three-phase circuit, we learnt that this phase shift is 30 degrees. Okay. Similarly, this phase shift is 30 degrees. Fine. Now what did we require? We required the phase angle between VRY and IR. Correct? So here is my VRY. Now this angle is 30 and this is IR. Correct? And this angle is phi. So what is the angle between VRY and IR? It is 30 plus phi. Please remember this. This is true for all combinations of voltage and currents. The angle phase difference will be 30 plus phi. Got it? Okay. So let us now move ahead. So my equation would be, yes, so I was talking about W1. So my equation becomes IL VL cos 30 plus phi. Similarly, if I talk about W2, then it would be V by Y multiplied by IB multiplied by the cos of the angle between V by Y and IB. Now I know all these things, right? So these are the line voltages, line current. But now here, now let us talk about V by Y, VBY and IB. So where is IB? Here is IB. Yes. And in this diagram, VBY is not there. Okay. So let me just draw that. Okay. Yes. VBY. So in earlier this thing, we had the diagram like this. So this was VBY. Correct? Yes. Right. So this was V. Yes. So this was V and Y and this was VBN. Right. And this angle was 30. Correct. Okay. And here IB was here. So this was IB. Fine. And this angle was theta, phi. But what do we require? So see, this is IB and this is VBY. Correct? And here we have this angle. So this total angle is 30. Okay? And this angle is phi. But we do not require these two angles. Correct? We require this angle. So what is going to be this angle? This is now 30 minus phi. Okay? Got it? Yes. So I shall erase this now. Fine. So here the angle would be 30 minus 5. Okay. So we got W1, we got W2. So what we are going to do is we are going to add these two together. So W1 plus W2. So it would give me IL VL cos 30 plus 5 plus VLIL cos 30 minus 5. Okay, so I will take IL VL common and I have cos 30 plus 5 plus cos 30 minus 5. We have seen such type of equations. Yes, so it becomes ILVL. Now what I will do to replace this cos A plus B plus cos A minus B, it is 2 cos A cos B. What is cos A? 30. What is cos B? 5 cos 5. Right? What is the value of cos 30? Come on. What is the value of cos 30? Root 3 by 2. Correct? Cancelled. So what is W1 plus W2? It is root 3 IL VL cos 5. See, we have derived the equation. Fine? Okay? It means it is giving you VL IL cos 5. Correct? So, if we talk about power, what was the power in our equation? If we talk about P, that is active power, it was VL IL cos 5. How will I find out that? W1 plus W2 upon root 3. Simple. Correct? So this will be P for me. That is the active power. What I will do is now, instead of adding these two, I will subtract these two. Now here I am assuming that W2 is greater than W1. It can be in either way. It can be W1 minus W2 also. Fine? Yes. So when we do that, we get VLIL. Obviously it is going to be common. So I am skipping that step. 30 minus 5 minus cos 30 plus 5. But here it is cos A minus B minus cos A plus B. Correct? So in this case, it is 2 sin A sin B. Sin 30, sin 5. Right? What is sin 30? Half. So VL, IL, 2 into half sin 5. Right? So what is W2 minus W1? VL, IL, sin 5. What is this? Reactive power, Q. So what is how can we calculate reactive power? W2 minus W1. Okay. But suppose I have to calculate power factor. How will I do that? Come on. Now I have W2 minus W1 and I have W1 plus W2. In one I have sin 5 and in one I have cos 5. So if I divide those two equations, what I am going to do is, please see carefully, root 3 W2 minus W1 upon W1 plus W2. So here I will get Correct? Yes, I can do that. So I got tan phi equal to root 3 W2 minus W1 upon W1 plus W2. Right? So what will be phi? What will be phi? It will be tan inverse root 3 W2 minus W1 upon W1 plus W2. Once I know phi, I can calculate power factor, which is cos phi, right? It means that this method helps us to calculate all kinds of power because it gives you W1, W2, and by adding the power, you get some power. By subtracting the power, you get some power, and you can also calculate the power factor. So this method is very advantageous. Okay, fine. Yes. So this is the same thing which we have already done. So I think we can skip this because I prefer doing the derivation by myself. Okay. Yes. So this is how we calculated power. We measured the power. So what is today's conclusion? Today we learned that three-phase power can be measured by 2-wattmeter method, and it is very useful to measure. It is actually, this method is quite useful when we want to measure active power, reactive power, and power factor. Secondly, one of the advantage of 2-wattmeter power method is it can be used for balanced load also and unbalanced load also. See, we need not bother about unbalanced load, but in practice it can be used. Okay? And when you have star connection, the neutral point is not required here. Fine? You can only, your wattmeter will work even if you don't connect the neutral point. Only 3 points are sufficient. Okay? So with this, we come to the end of this lecture. See you in the next lecture. Thank you.